Hello, I'm Claire, and as part of the Fathoming the Future project for the Maritime Archaeology Trust, I'll be going through this presentation on archaeological drawing. This presentation will go over the basics of archaeological drawing, the principles and purposes of it, and some considerations when it comes to underwater sites. First of all, I'd like to give you a brief introduction to archaeology as a science, as I believe we can't fully discuss archaeological drawing without going through this history. Effectively, archaeology developed out of an aristocratic interest in antiquity, and gradually became a more structured methodological science. Archaeological drawing is more than just artistic illustrations, it's a crucial tool for the recording and dissemination of information. Its development aligns closely with the growth of archaeology as an academic discipline. Archaeology developed out of a general interest in antiquities that became more of a science over the 18th and 19th centuries. Some would say that Pompeii was the first real site of archaeological excavations, where we can see the progress of archaeology as a science in the history of the site. At first, tunnels were dug into the site to extract valuable and interesting artifacts, which would now be regarded as special finds in an archaeological dig. But over time, practitioners realized the value of stratigraphy, the layers of soil which the finds were buried in. Eventually, they organized more rigorous and methodological excavations. Some famous pioneers within archaeology, among many others, will be touched upon in this introduction, due to their influence on the development of archaeology as a science. The first of the famous practitioners who we'll discuss today is Heinrich Schliemann, seen on the left of our slide. Schliemann is a famously controversial archaeologist who's not primarily known for his methodologies, but rather for his enthusiasm and his dedication to finding the site of mythical Troy. He's also credited with having found Mycenae. He's known for having had little regard for the context of the finds, as he desired to ensure all of the most impressive artifacts he had could be dated within a certain time period that would allow him to identify the sites as from the Iliad. Later in his life, he took on the help of William Dürpfeld, who influenced him to adopt more scientific methods. By the end of his life, he carefully recorded his excavations, preserved the ordinary along with the extraordinary, was prompt about publishing his reports, which makes his legacy something of a mixed one. In contrast, Sir William Matthews Flinders Petrie, on the right of our slide, is most famous for developing theories about the importance of stratigraphy, the layers of soil that we can find when digging at a site. These can give us an impression of the history of a site. Stratigraphy is most clearly detailed in section drawings, which we will talk about later. Augustus Pitt Rivers, who you can see on the right of the slide, served in the army in India and had a fascination with typologies and objects that clearly developed in an evolutionary manner. At first, his interest was primarily in weapons, but over time it developed into more of an interest in antiquities. He was really interested in the value of drawing and how it might change over time, and indulged in a kind of experiment akin to Chinese whispers, where he would have many artists copy the same drawing, except each artist was copying the impression from the artist before them. At the end, he would compare the last drawing with the first to see the sort of change within these drawings. Due to his interest in drawing and his development of certain typologies within antiquities, he prioritized drawing as a medium of expression, and his published works relating to excavations show drawings have a pride of place. Sir Mortimer Wheeler lived much later than the other archaeologists here, but was another major figure in the development of archaeology as a scientific endeavour. He was particularly interested in developing methodologies that would be applied across all sorts of sites, such as using the Cartesian grid method, which is a sort of superimposed grid upon a site, to measure the distance of features within an excavation. These methodologies are still in use today and are very useful when it comes to the publication of sites, as they help scholars who have never seen the site to visualize it, which allows for a better understanding of the context of the finds they study. So now we'll move on to an overview of the types of archaeological drawing. There are three main types of archaeological drawing: site plans, which give us a bird's eye view of a site, section drawings, which give us an impression of the stratigraphy of a site, and special finds drawings, which are designed for publication and allow for further study of the specific artifacts found at a site. So first of all, site plans, such as the one on the right of this slide, are diagrammatic, so they are representations of the most important information about a site. They are drawn from a bird's eye view looking down, and they usually have a compass showing which way is north and a scale to show the reduction. Generally, they are drawn at a scale of 1:20, where 1 centimetre on the plan represents 20 centimetres in real life. The most important thing is that these plans are to scale, and the relative distance of finds are recorded accurately. Some site plans will have more detail and may record information such as the depth of the trenches dug. To record these measurements, the archaeologist may have a baseline from which they measure. To do this, there is often a tape strung up between two stakes across section of the site, and then archaeologists take all their measurements off this baseline using another tape measure and a weight on a line, called a plumb bob, to measure the depth and position of accurate pinpoints, such as the deepest point in the trench or the edge of a wall. They may use a more complicated surveying tool, which involves reflecting light using a prism to get the same measurements, or employ the method of having an imaginary grid, the Cartesian grid mentioned before, across the site and lining up their drawings with this grid, in order to have a uniform baseline from which to measure. In all these methods, the most important aspect is scale and accuracy of the drawings, so they will be done meticulously on graph paper, and getting an accurate, objective record of the site is the aim. These site plans will be primarily used to see what the site looks like as an overview, and so that archaeologists can understand the relative distances of artifacts found from each other. On to section drawings. Section drawings record the cross-section of the trenches dug, which allows for an analysis of the stratigraphy of the site, and for the relative dates of various finds found within them to become clearer due to an understanding of the layers that they were found in. As you can see on the slide, the sections primarily focus on layers that have been discovered, and are drawn to scale with an interest in detailing the contents of each layer. For instance, the top layer of soil or turf will generally have very little of archaeological significance, but the layers below represent finds from successively further back in time. These drawings are very important when it comes to communicating the detailed context of particular finds. Sections provide information on how features and sites are used or change over time, as the cross-section of a site often shows overlapping time periods or cut into features. At the moment, there is a lot of focus on stratigraphy for the context of finds when it comes to research within archaeology. Thirdly, special finds. Special finds are finds that are clearly of archaeological or historical value. They have to be studied individually and drawn and recorded with particular attention to detail. As you can see from the slide, when drawing a special find, for instance a telescope, one has to pay attention to both its surface decoration and the characteristics of it. These drawings are very technical and are drawn at a much bigger scale so that all of the details of the object can be recorded accurately. A contour gauge, such as the one shown on the left of this slide, might be used to draw the exact profile of an artifact, as long as using such a device would not damage the special find. As you can see from the technical drawing on the slide, the scale of the drawing, in this case 1 centimeter is to 2.5, and a ruler for an objective scale is always recorded. Some other remarks, such as the material or any identifiable features, would generally be noted if such a drawing was included in the publication. In general, the principles of archaeological drawing are equally applicable to maritime archaeology, as they are to land-based sites. As you can see from some of the materials published by the Maritime Archaeology Trust, or one of their own excavations of the Flower of Uji, the diagrammatic drawings produced for publication are quite similar to those from land-based excavations. This is due to the consensus on how such drawings should be done, in order to make the comparisons of sites easier for archaeologists and scholars. If you look at this plan in detail, you can see that there is a map included to help locate the site, and the direction of the compass direction is recorded. Due to different kinds of site, section drawings can end up looking quite different, but they follow the same rubric across all sites. The wooden remains of shipwrecks tend to only survive in very scarce conditions. Conservation of the organic remains is a top priority for the excavators. Generally, wood only survives due to being untouched in an anaerobic environment, such as the layers of mud encasing wrecks in the site of Thonis Heracleum in Egypt, and otherwise we are often alerted to the presence of a wreck site from inorganic materials that remain, such as large numbers of amphorae from Roman period wrecks. While the conventions of recording and publishing underwater sites are the same as those for land sites, the challenge in excavating these sites can be much greater, requiring specialized equipment and experienced divers. So as you can see from this slide, we have a section drawing from the Flower of Uji, where you can see the principles and scale are very similar to that of a land-based site. So finally, special finds from both land and underwater sites are treated very similarly when it comes to archaeological drawing. In this case, the special find, a bell from the Flower of Uji shipwreck, which was excavated by the Maritime Archaeology Trust, is first photographed and examined visually and by hand, then drawn upon graph paper with a lot of attention paid to the scale. Then this drawing is transformed into a digital drawing that can be used in a publication, with the scale still included. As you can see, both the size of the object and its surface decoration have been drawn very carefully. In conclusion, as you can see from the various drawings in this presentation, archaeological drawings are designed to convey accurate information in a manner that is comparable to other site drawings, in order that the information is as clear as possible. The plan of a site gives a very clear overview of the relative distances of landmarks and gives someone an idea of what it would be like to visit that site. Section drawings show the stratigraphy, which is then helpful as it identifies the layers of history within a site. These can be used to investigate the context of finds that have been published from a site, and these special finds will then be published in their own right, will have to be drawn in detail, often in real-life scale or perhaps even larger than life scale, with very small finds and intricate designs requiring such large scales. The standardization of the way in which we draw these finds helps scholars to amass large categories of a certain kind of object, for instance hairpins, and from this be able to develop ideas about their provenance, or perhaps a certain style that was in fashion for a period in antiquity. The standardization and methodology of recording visual information accurately has been very important in the development of archaeology as a science. The development of scientific methodologies has helped to develop archaeology from a hobby that wealthy people engaged in, purely to find interesting objects for their private collections, to one of our best ways to find insight into the past. While it is difficult to explain all these methods, and this is a very brief introduction to the topic, I hope that you can see the importance and the difficulties that come with recording visual information accurately. Of course, on every modern dig, there is a camera on site, and many photos are taken as the dig progresses, both of the site and of the finds, so some might argue that archaeological drawing is no longer needed. However, there is much to be said for the diagrammatic, simplified version these drawings provide of a site, as it conveys the most important information in the most accessible way, especially to someone who is familiar with these site drawings. It is therefore very important when it comes to publishing a site and allowing people to study it further, and it has underpinned much of the developments in archaeology over the last century, as people compared artifacts from sites and have been able to make great strides in identifying them, due to the accurate publication of drawings of them. For more information about the Flower of Uji, please see the blog in the description, which is on the Maritime Archaeology Trust's website. This blog post details the fascinating history of both the ship itself and the excavation. Thank you, and goodbye.